Hello and welcome back to part 2 of this variable pattern tutorial. You probably want to watch part 1 first to understand what's going on, but this is part 2. One thing I forgot to do last time that I wanted to mention is that I did show the circular pattern, how do you do the spiral staircase idea, but I didn't go over how you would change the spacing as well. And one way to do this would be to create a sketch, an arbitrary sketch, doesn't really matter where it is, and I'm going to use it to define a bunch of random points like this. And then if I were to use a point pattern, then I can do the same thing again. Pattern my counter, sketch, revolve feature. Starting point is this, and locations are gonna be all these points. And if I hit apply per instance, now you can see I've got my, of course it looks a little bit weird because they decrease by a fixed increment each time, but the spacing is driven by this sketch, so you can literally do kind of what you want. So that's a different way. By using different types of patterns, you can create different end results using kind of the same technique. And now I'm going to go over another option, and that would be if you wanted to not have just increments, but actual kind of random arbitrary steps, basically different diameters for each one, or some specific pattern, which was kind of the middle example in the original Tutorial Toby video, where he's got like one big, one small. You could alternate or do some other patterns, and I'm going to go over how to do this. So the trick for this one is to know that you can use an array as a variable. The only constraint I think is you have to use the any type, and I'm going to call this diameters, plural. And then to create an array, I'm going to start with this, and I'm going to say 200 millimeters. You do have to put units because it's or I guess you could multiply the value as well, but it's probably better to just use actual values, so you know where you're going. I'm gonna let's do another one, and then just to make my life easier, I'm just gonna copy and paste this a couple times to create an array with a bunch of apparently I screwed it up. Yes. I need at the end to close it. Here we go. Now it's kind of annoying to edit in here, but you can, if you need more space, you can use this, the variable table, and that makes it a little bit easier to work with. Another thing is I just put a bunch of random numbers in there. I don't know how long it is, but you can use a variable for that as well. Again, using any, I'm gonna say number, and this will be size of diameters, and this tells me there's 18 in there currently. So now the difference becomes in here, and it's going to be very similar again, right? We're just going to say in terms, instead of all this, we're going to keep the divide by 2, but we're going to do diameters. And how do you access a specific spot is we will use our counter I. So this will be diameters index I, and over 2 should be fine. So that gives us 100, which is 200 over 2. And now, if I unsuppress this, now obviously I still need to pattern I, the sketch, and the revolve. And now you can see that you're getting this kind of fun pattern. Now the fun thing that you could do is, instead of using the instance count, you could use the variable number, and now it's basically driven by this. So if I were to remove a few at the end, going too far, start on the end on the 175, basically the pattern will now follow whatever I want. And if I wanted added a 300 diameter in there somewhere, I can do this, and here it is. So here's a way to get completely arbitrary sizes. And actually, one thing you can do as well, going back to what we were saying earlier, is you could also change the spacing the same way. You could say spacing is of type any, and let's go with a bunch of values. And actually, one thing that might be interesting, and you can still use variables that you've defined earlier. So we're going to go spacing, then 50 millimeters, then 22 millimeters, for example. And I'm actually going to only add 3 values in there for now. And now the sketch is not happy, but I can do dimension between here and now I don't want the origin because I do want it to solve every time. So I want to, let's use the bottom of the cylinder, and in here we're going to use spacings of I, and we've got 20, which is the first one. Now the interesting thing is now, right, of course, wait, hang on, that does not look right. Oh, it's the distance from the bottom, of course. Yes, okay. Right. So it was working all along, but really the spacings, actually Toby was running into that as well. Its distance from the origin, each incremental one is based on, because my dimension, this dimension is from the bottom of the cylinder, not between, that's not the spacing, that's the absolute value of each one. So anyway, that's what was going on. And what happens is if your counter goes out of the bounds of the array, so if your I goes longer, so let's just say if instead of this I increase this number, basically it will use the first value. So all these extra instances are all down here where the first one is, because they are using this 200 diameter and this 20, which is the distance from the origin. So that's what's going on here. Okay, so there's one more use case I wanted to go over. So until now we're using I in increments of 1, which works well for if you're using an array, or if you want to do, an increment of a certain distance with each instance of the pattern. But there's another use case where you might want something different. So let's say, what did I just do? Duplicate. That's what I meant to do. Let's say I'm not going to use an increment, but I want to use a formula. You know, let's, for example, like a sine wave. So I want these to follow a formula of some sort, mathematical formula. Obviously, I don't really want it to change shape if I add an instance. So I don't want it to go from 0 to however many instances they are. So the way you would do that is you would change the increment. Instead of being +1, what you want is 1 over, and its instances -1 is the magic number. And I'm actually going to copy this because you want to increment by this much, and then your starting point is not -1, it's -1, the same amount as 1 increment, basically -1 increment is where you want to go. So now by doing this, I will not go from 0 on the first instance to 1 the last one. So you can use it in a parametric curve in the mathematical sense of the term. And I'm going to show an example of what we could do. So let's say I'm going to do cos of I, we'll use I, times it wants degrees, so times whatever the range I want to be, let's say 180, for example, degrees. And I think that's good. Nope. Oh yes, times, that would just be going between 1 and 0, basically. So times whatever my base diameter is. So let's go to 100 millimeters. And I have a parenthesis problem. Probably need. That's the problem with editing equations. That I really wish they would make this box bigger, because right now it's not super easy to see what you're doing wrong. What? Not okay. Cos, that's an angle, I times degrees times 200 millimeters. There we go. So this gives me my 100 here, and if I go, I think, let's get rid of that, unsuppress this. Obviously that's not quite I want. Distance I want spacing is what it's called. Alright, so there we go. There's something, oh yes, because I'm going negative. So here it's, you can see the sketches are kind of inverting beyond the 0 point. So I should really be taking the absolute value of this. So we'll add absolute of my cos. And that should work. There we go. So now I've got an example of pattern following a curve. And that's basically how you do that, by making your eye go between 0 and 1. Then you can do whatever you want, basically. Sky's the limit, kind of. And you could also use, to make it a little bit easier to control, I've got 180 degrees, but I could say, you know what, let's make this a variable, I call it param range, for example. and that will be an angle, and let's say I'm gonna make it 270 here, and now I can control it from here, whatever I want it to be. And the other thing too is obviously this is independent of how many instances I have, so if I make this 25, it will recompute, and you still start at 1 and end with 0. So these are independent. Anyway, hope that's helpful. And obviously you can use, you can really get pretty involved if you have some sort of mathematically defined shape that you're trying to do. You can have your sketch can use eye, you could have it at an angle as well if you had some weird thing going on. You could also use multiple sketches and feature working together, so there's really the sky's the limit. But knowing that the key trick is setting up your parameter like this, so that it goes from 0 to 1 over your range, so that you get the same general shape regardless of how many instances you use. That's really the main thing. Anyway, hope that was helpful and not too much rambling. Probably won't use this every day, but it's fun to play with. I'm sure there's some funky 3D printing applications for things like that. And let me know if you have any questions.